I am in present of you coming with the topic of solution third for expressing the way of ppm. As you study about ppm in previous class, that is most applicable for the 12th students, and also the preparation and study for the student of JEE Mains and the NEETs. Today I am in front of you expression ways of ppm. There are three ways of expressing ppm, that is one, mass to mass, point two, volume to volume, volume to volume, and the third point is mass to volume. Point one, mass to mass. The expression of ppm that can be derived from mass to mass, that is the millionth times of ppm. Mass to mass is the ratio of mass of a components and the total mass of the solution. Again, come to here about the mass to mass. Mass to mass equal to the millionth times of the ratio of mass of component of solid. Mass of components, that is solute. Solute the millionth times of the ratio of mass of solute and the total mass of the solution. Point two, that is the volume to volume. It can be derived as the millionth times of ratio of volume of component and total volume of the given solution. Again, listen about the relation volume to volume, that is the ppm of volume to volume is the millions of times the ratio of volume of component and the total volume of the solution. ppm of volume to volume, that is the volume of component, volume of components solute upon total volume of the solution into millions of times. It is also defined as V of solute upon V of solute plus V of solvent into 10 to the power 6. The third way to express ppm is mass to volume. Mass to volume. The ppm of mass to volume can be said to be as the millions times of ratio of mass of component or solute and the total volume of the solution. That means mass to mass volume equal to volume of component upon mass of component. Mass of component upon volume of the solution into millions of times. That can be also derived. Mass upon V is mass of solute upon volume of solute plus volume of solvent into millions of times. This can be mass upon mass, V upon V, and M by V. These are the expression ways of the ppm of a solution, that is depends upon mass to mass, volume to volume, and mass to volume. Their ppm is the millions of times to the ratio of component, that is solute, and the solution. Now I am coming to discuss about the mole fraction. What is the mole fraction? Mole fraction, according to the solute and the solvent in a solution, how much ratios of solvent and the solution is present in a solution. That is also define the molecular activities between the solvent and molecular activity in the solute that can be depends on the internal static force of attraction between the molecules of solute and the molecules of solvent, and the between molecules of solute and molecules of solvent as a solution. So at first we come to express about the mole fraction, that is mole pravaj. It is the ratio of number of mole of particular component. It is the ratio of component of mole to the mole to the mole respect to another component of a solution. The mole respective to the all components of solution is the mole fraction respect to the mole of the component as solvent. Hence, we come to know here, therefore, mole fraction of component A, mole fraction of component A, that is solute, is XA. Consider XA is the mole fraction of the component. Is for the solute and it is as per number, so it can be derived as Na. And for component B, that is solvent, is Nb, and Za is the mole fraction. If Za is the mole fraction, so Za equal to Na upon Na plus Nb. Solute number of mole fraction of solute upon the number of mole fraction of the solution as per compound wise. Za equal to Na upon Na plus Nb. Therefore, we can derive it as for the second component Zb equal to Nb upon Na plus Nb. Therefore, Za plus Zb equal to Na upon Na plus Nb plus Nb upon Na plus Nb. Have any problem? This both equation first and equation second is added. Za plus Zb equal to the value of Za and value of Zb given for the addition. So it must be written as Na plus Nb upon Na plus Nb, that is 1. That is 1. This is the mole fraction. It conveys about the ratio of component of mole to the mole fraction of the other component of a solution. If Za is the first component mole fraction, that is Na plus Nb, and Zb the second component mole fraction, that is Nb Na plus Nb. That the equation first and equation second, if when added, it further produce a result 1. This mole fraction is very important for the numericals in the class 12 for the JEE Mains and NEET, and also how to express a mole fraction of a solution separating by the solute and the solvent that can be produced here. Their ratio is B constant as 1. So this expression is very important for the class 12 and also helpful for the study JEE Mains students and NEET. Now the class is over, but some message to you. अगर मोल प्रभाज, मोल फ्रैक्शन और पीपीएम की क्लास इंटरेस्टेड एंड काफ़ी उपयोगी समझ में आता है, आपकी समझ में इजियर सरल रूप से अगर आ गया है तो कृपया इस प्लान को सब्सक्राइब, शेयर और लाइक अवश्य करें। ये आपकी एक खास ड्यूटी है, आपकी एक खास दायित्व है जिसे आप ही के द्वारा इसे सब्सक्राइब, शेयर और लाइक किया जा सकता है। फॉर दिस काइंडनेस एंड फॉर दिस एक्टिविटीज you all are respected in the view of online class, and now the class is over. Thank you to you. I meet you at next class tomorrow.